Okay, we'll talk about the inverse of the extended basic exponential function. Very famous function. Okay, so you see what? What's the most fundamental thing you see here? You see something you know how to do? How about basic exponential function? You know how to do that? So ignore the rest of it, you know what that means. Well, the extended you understand. Okay, but let's just start with the basic exponential function. What do? Well, reflex. Notice I've left out the negative 1/2 and 1/2 because I now understand the function, right? And you get 1/4, 1/2, 1, 2, 4. And you sketch the graph. Okay, so here's 2, here's negative 2, you subdivide that, you got 1, you got 1/2, negative 1, negative 1. You got 1, here you got 1/2. And up here you've got 4. You don't really need the negative y-axis because none of the values are negative. In other words, the range of the function doesn't include negative numbers. So there you have it, and now you subdivide 1 down to 1/2 and 1/4, so you can plot these points. Didn't need the negative 1/2 and the 1/2 either, but we just got out of habit sometimes. And you sketch the graph. Okay? So when you see extended basic exponential function, your reflex is don't shoot anybody dead. Your reflex is do this. Okay? I did it while saying words in less than 2 minutes. And I didn't hurt myself, I didn't fall down, I didn't break anything. I'm proud of myself. Okay, there it is. Now, we haven't addressed this inverse word, right? But this is y equals 2 to the x. Okay, the inverse function. Now, we stop there for a minute. Yeah, we put a line here, okay? And we go ahead and make 1, 2, 3, 4, 5 lines across here. Okay? And we write down the numbers that we have here, except the numbers that are in the first column go in the second column. So these are going to be our y values, negative 2, negative 1, 0, 1, 2. Okay? And then, where do you think the numbers in the y column here are going to go?
The x.
In the x column over there. Okay? So we're going to have 1/4, 1/2, 1, 2, 4. Well, it turns out that it is a good idea that I had the negative y-axis here, because when I plot these, I'm going to have some negative numbers, right? Okay, so let's see, negative 2 is going to go, well, it's going to go that far below the axis. You can say negative 2 there, negative 1 here. And now I can plot, except, okay, I've got 1/2 here. I'm going to need 1/4 because that's one of my x values now, right? And now I plot 1/4, negative 2. Well, that's here, right? 1/2, negative 1. That's here. 1, 0. That's here. And 4, 2. Well, I had a little bit of luck down here. But I'm almost out of luck because 4 is going to go all the way out here. I'm going to have to extend my y-axis. Didn't think ahead far enough. Well, I didn't want to give it away. No excuse. Okay? So I can get that off just a little better. This deserves to be really pretty, doesn't it? What you think? Well, think so or not, I'm going to make it absolutely beautiful. Except this is awful dusty. I don't know if I'm going to achieve pure aesthetic beauty out of this or not. So I'm going to put 4 here. I'm scratching it up just a little bit. That's pretty close. Okay, so I'm going to have then 2, 1, and 4, 2. Right? And these would be the points on the extended, on the inverse of the extended basic exponential function. Okay? So here's the extended. Y equals 2 to the x. And here is a graph of the okay. Now, a term I don't need the word extended, so let's get smudging the board. The base of the function is a number that we're raising to the x power. We could have the 3 to the x function. What would the base of a 3 to the x function be? Give you a hint now. Base of the 2 to the x function is 2. Base of the 3 to the x function would be 3. Very good. Okay. Okay. The inverse of a basic exponential function I should have said y equals. This is red. As the log base 2 function. The log base 2 function is written log sub 2 of x. Log stands for logarithm. Okay? Now, if I wanted to find the log of 1.5, what would I do? Base 2 log of 1.5 means I'm using this curve, right? And log base 2 of 1.5 means x would be 1.5, right? If x is 1.5, I can find the point in the graph corresponding to x equals 1.5, right? Okay, so I could say, for example, here's 1.5, okay? Here's the graph point. Where x equals 1.5. That's this point here. And right here, That's the y-coordinate to the graph point where x equals 1.5. What do you think that y-coordinate is?
About 1/2.
Pretty close to 1/2. I know it's not 1/2 because this thing is curved. And if I go in a straight line from 1 to 2, this point's going to lie a little higher than that straight line, isn't it? This thing kind of humps up over the straight line. Now, unfortunately, my line wasn't really quite parallel to the x-axis. And from where you're sitting, it looks a whole lot like 1/2, even though if you look really close, there's a little, but the 1/2 and the green line have a little space between them. So 0.6 would be actually a better estimate, okay? But you could make that estimate, right? And one thing I'm probably going to ask you to do for homework is construct this graph and then make some estimates of what the y value is for given x values. So now we can say that this and this go together to tell us that log base 2 of 1.5 is approximately 0.6. Now you don't, unless you've seen it before, have any idea what the log functions are good for. Okay? And one thing they're good for is for solving equations that involve exponential functions. But we'll get to that a bit later in the course. Okay, we're laying the foundation right now. So really what I'm showing you what the basic log function is. The one corresponds to base 2. Okay? Base 10 logs are important too. And base 2 and base 10, well, base 10 logs are on your calculator. Base E logs are in your calculator, but we've got to get through compound interest, which is something everybody should know by the time they get here, but nobody does. For some reason it's been dumbed out of the curriculum. But you have classes that talk about a little personal finance, but you don't know what compound interest is, right? Something's wrong out there. Anyhow, it's not that hard, but you got to get your wits about you. And it's something you really need to understand, just for your own personal understanding of the way investments work. Okay. Okay. So here we have it. Okay. Now, could you do the inverse of the 1 over x function? Basic reciprocal function? Well, can you make the table of the basic reciprocal function? Well, if you can't, you're behind and you need to be able to, but make sure you get there quickly. Okay? Can you do the inverse of that graph? You sure can. Can you do the inverse of the basic squaring function? I mean, it's always the same. You make your table and you reverse the columns and you sketch the graph. Okay? There's kind of symmetry in these graphs, isn't there? Sort of, kind of reflection symmetry. Okay? We'll talk about that. So if you have a function, you can always do the graph of the inverse, right? Now the inverse that you get when you do that is not always a function. Because what do you know about functions? If I give you x, how many answers can a function possibly give you? 1. It's got to be just one answer. Okay? Well, if you do the inverse of this thing, you get this thing. And for given x, there's one up here and one down here. Point up here and a point down here, right? You know what you do about that? Take half of it and throw it away. Okay? Not complicated at all. In mathematical form, terminology, we say we choose a branch. There are 2 branches, one that goes this way, one that goes this way. We take this one, throw the rest away. Means we restrict the domain of the squaring function, so we can do that. You know, it's not difficult to understand, but it's terminology. And you don't need to write that one down. Do that one a little more slowly when we do it. Okay? Okay.